Hello everyone, how are you all? I hope you all are keeping fine. Can you recognize the topic to be discussed today? The picture here shows magnets. Make a guess. Okay, let me make it easier for you. So now this picture, look at this picture. This is also a similar kind of picture. Now can you get the topic? Oh yes, you're right. Today we will study about magnetism. First of all, let us discuss what is this magnetism. Magnetism is an invisible force that pulls certain substances towards a magnet. Magnets exert a force of attraction on materials such as iron, steel, cobalt, and nickel. In our daily life, we come across many objects that are attracted by a magnet. An iron lock? Yes, an iron lock is attracted by a magnet. An iron key? Yes, iron key as well. Any substance that has the property of attracting iron and other materials such as steel, cobalt, and nickel is called a magnet. The property itself is known as magnetism. Magnetite, an iron ore, was first magnet that was discovered. Let us now study more about magnets. Natural and artificial magnet. Magnets can be natural or artificial. A magnet which occurs naturally and has the ability to attract magnetic materials is called a natural magnet. Magnetic rocks such as those found by ancient Greeks are natural magnets. The first known magnets were pieces of lodestone and ore of iron oxide found in large quantities in Magnesia that lies in Asia Minor. This ore was found to possess two properties. First, it attracts small pieces of iron. Secondly, it sets itself along a definite direction when it is suspended freely. The Chinese earlier than 2500 BC used these pieces to guide their boats. The pieces of lodestone found in nature were later on called natural magnets. The word magnet has been derived from magnesia. The magnetic properties can also be imparted artificially to some materials. Such magnets are called artificial magnets. Artificial magnets are generally made from iron, steel, nickel, cobalt, or their alloys. Artificial magnets come in a variety of shapes. It can be a bar magnet, horseshoe magnet, or a cylindrical magnet. Bar magnet is a long rectangular bar shown in the figure. It is the most common magnet used in everyday life. Second picture shows a horseshoe magnet. It is a magnet that is bent in U shape. These shapes make it stronger by pointing the poles in same direction. The third picture shows a cylindrical magnet. This magnet is a magnet designed and constructed in form of long cylinders. Magnetic and non-magnetic materials. Some substances are attracted towards a magnet while others are not. Accordingly, they are classified as magnetic and non-magnetic substances. Substances that are attracted by a magnet are called magnetic substances. For example, iron nail, iron knife, cobalt coin, steel spoon, and so on. While the substances that are not attracted by magnets are called non-magnetic substances. For example, chair, plastic spoon, glass, paper, etc. The substances have the ability to get magnetized. They are called magnetic substances, while the non-magnetic substances cannot be magnetized ever. Now, test yourself. The question is, any object in silver color can be attracted by a magnet. Judge yourself. Say yes or no. Any object in silver color can be attracted by a magnet? No, it is just a myth. The fact says objects made up of iron, cobalt, and nickel and their alloys can be attracted by magnets. These objects may be in silver color or they might not be silver in color. Let us move forward towards a magnetic compass. So, what is a magnetic compass? It is just an instrument used for navigation and orientation. It shows directions. Let us study about the types of magnets. Depending upon the origin of magnets, there are two types of magnets: permanent magnet and temporary magnets. Permanent magnets are generally made up of steel. They retain magnetism. They are used in magnetic compass and door latch. Temporary magnets are made up of iron. They loses magnetism after some time. They are used in electromagnet. Permanent magnetism is a property that is inherited by permanent magnets, and temporary magnetism is a property that is inherited by temporary magnet. In a permanent magnet, the north and south poles are fixed. They cannot be changed. But in case of temporary magnet, the north and south pole can be changed. That is, the position of north and south pole can be changed. In case of a permanent magnet, the strength is fixed. It cannot be increased or decreased. But in case of a temporary magnet, the strength keeps on changing. Electromagnet is also a kind of magnet that can either be temporary or permanent, depending upon the material of core. If a soft iron piece is taken as a core, we get a temporary electromagnet, whereas if a piece of steel is taken as core, we get a permanent electromagnet. Let us now study a few uses of magnets. Magnets are used in electric bell. They are used in magnetic compass. They are used in maglev trains. They are used in refrigerator doors. They are used in TV and computer screen. They are used to separate magnetic and non-magnetic substance. They are used in cranes. They are used in speakers which convert the electrical energy to sound energy. Magnets are also used in tape recorders and telephones. They are also used in electric motors and generators which convert electrical energy to mechanical energy. Now let us talk about the properties which a magnet possesses. Properties of a magnet. A magnet has four properties. The very first is attractive. Second is directive. Third says like poles repel and unlike poles attract. Fourth property says magnetic pole always exist in pairs. Let us have a look at the very first property. The property of a magnet to attract magnetic substances towards itself is known as attractive property of a magnet. The property of a magnet is always maximum at the ends, called the poles of the magnet. The attraction is maximum at the poles of the magnet. To show the magnetic force is always maximum at the poles, you need a magnet and some iron fillings. If we look at the picture, we have a horseshoe magnet and some iron fillings. Take some iron fillings and spread them on a table. Place a magnet over the iron fillings and then lift the magnet. You will observe that most of the iron fillings stick to the poles of the magnet and very few or no iron fillings stick to the middle of the magnet. So it concludes the poles of the magnet have maximum magnetic force. Let us now study another property, that is directive property of a magnet. A magnet always aligns itself in north-south direction when suspended freely. This is known as directive property of a magnet. Directive property means telling the direction. The end of a freely suspended bar magnet which point towards the geographic north of Earth is called the north pole of the magnet, whereas the end that points towards the geographic south is called the south pole of the magnet. The imaginary line joining these two poles of a magnet is called a magnetic axis. Now, if you want to do the same experiment at your home, how would you do it? To prove that a freely suspended magnet always points in north-south direction, what do you need? You need a bar magnet, a wooden stand, a string, especially you take silk as a string, a piece of chalk. With the help of piece of chalk, mark north, south, east and west directions on a table. After this, suspend a bar magnet freely from a stand. Place the stand on the markings. Let the magnet come to rest. Then again disturb the magnet by pushing one of its ends with your finger and let it again come to rest. After some time, when it holds the rest position, you will observe that both the times one of the ends of the magnet points towards the north and the other points towards the south, irrespective of whether it is made to rotate clockwise, anti-clockwise, or you are pushing it in any other direction. So we conclude here that a magnet always aligns itself in north-south direction when suspended freely. Let us come to another property. It says, like poles repel and unlike poles attract. Yes, like poles of two magnets repel each other, while unlike poles of two magnets attract each other. The given figure shows south-south will repel, north-south will attract, and north-north will repel. The fourth property of magnet says magnetic poles always exist in pairs. We know that a magnet has two poles. These poles always exist in pairs and can never be separated. To find out whether the magnetic poles can be separated or not, you need to have a magnet. Actually, you need two bar magnets. Take one of the bar magnets and make two halves of it. Now take the ends of each half towards the same pole of the other bar magnet one by one. You will observe that while one end of the magnetic piece attracts the bar magnet, the other one repels it. This shows that the broken piece of the magnet have both the north and the south poles. If you go on breaking the magnet into smaller pieces as shown in figure, each piece is again found to be complete magnet with north and south poles. This concludes that magnetic poles can never be separated, they always exist in pairs, or it will be good to say magnetic poles can never be separated, or a magnet do not have monopole. Let us now move forward to study the law of magnetism. The law of magnetism is something that is very much usual and it is one of the properties of magnet. It says like poles of two magnets repel each other while unlike poles attract each other. Now let us study the test of a magnet. What do you mean by the statement test of a magnet? Yes. Now we will study the test of a magnet. Anything, any specimen, any material that you have in your hand, you need to test it whether it is a magnet or not. So, Repulsion is the surest test of magnetism. Only repulsion between a specimen and a magnet allows us to conclude that the specimen is a magnet. Attraction between specimen and a magnet only suggests that the specimen may be a magnetic material or a magnet. Remember, it can be a magnetic material or a magnet. But repulsion is the surest test. It does not give you a dilemmic situation. It tells you the correct part. It is the specimen is a magnet or not. Let us move forward. To know more about a magnet, we need to study about the magnetic field around a magnet. The region around a magnet where its magnetic influence can be felt is called the magnetic field of a magnet. Magnetic lines of force. The magnetic field can be represented by a set of imaginary lines. If we want to study the magnetic field, we are drawing certain imaginary lines, curved lines, towards a magnet that originate from north and goes towards the south. The strength is maximum at poles of these lines and it is minimum in the midway. These imaginary lines are known as magnetic lines of force. To judge these lines, to understand, to feel these lines, you need to take a bar magnet and place it under a sheet of white paper. Now sprinkle some of iron fillings evenly on the paper. You will notice that iron fillings arrange themselves in a definite pattern of curved lines around a magnet. This happens because of the magnetic field present around a magnet, which cannot be seen but it can be felt or experienced. The curved lines formed around the magnet are the magnetic lines of force. The direction of magnetic lines of force is from north pole of the magnet to the south pole of the magnet. A magnetic compass is an instrument that can be used to plot the magnetic lines of force. Place a magnetic compass on a wooden table. The magnetic needle of the compass will point in the north-south direction when it comes to rest. Now bring a bar magnet near to the magnetic compass. You will notice that the needle comes to rest in a direction other than north-south. Now place the magnetic compass at different points around the bar magnet. As the compass moves from one point to another, the direction of needle will keep on changing. Thus, we will see the space around a bar magnet influences the needle of magnetic compass. This space has a force in that region that we call magnetic fields. Magnetic field. Now let us move forward. Now let us pay attention to certain properties of magnetic lines of force. Each magnetic line of force is a closed, continuous curve. The line of force never intersect each other since they mutually repel. The direction of magnetic line of force at a point indicates the direction of magnetic field at that point. These lines originate from the north pole of the magnet and end at the south pole. This means their direction is always from north to south externally. Since the magnetic field is stronger near the poles, these lines are maximum near the poles. They contract as they bend along the length of the magnet. Let us now study about the Earth's magnetic field. Why do two bar magnets always align themselves in geographical north-south direction when suspended freely? Yes. Can you tell me the reason? Yeah. It happens because Earth itself acts like a huge bar magnet whose magnetic south pole is near the geographic north pole and the magnetic north pole is near the geographic south pole. Therefore, When a magnet is suspended freely, the north pole of the suspended magnet is attracted by the magnetic south pole of the earth and hence points towards the geographic north pole. Similarly, the south pole of the suspended magnet is attracted by the magnetic north pole of the earth and therefore it points towards the geographic south pole. Do you know? An iron rod buried inside the earth along the north-south direction becomes a magnet. Yes, if an iron rod is buried few meters inside the earth, keeping it along the north-south direction, after some days, it is found that the rod becomes a weak magnet. It means it gains some magnetic properties from the earth's magnetism. It is possible only if earth itself behave as a magnet. Now let us study a bit about neutral points that are obtained on plotting the magnetic field lines of a magnet. If a magnet is placed in a horizontal plane with its north pole facing towards the geographic north and the magnetic field lines are plotted, we obtain two neutral points, one on the either side of magnet on its broadside on position. Similarly, if the magnet is placed in a horizontal plane with its north pole facing towards the geographic south and the magnetic field lines are plotted, we obtain two neutral points, one on either side of magnet on its end-on position. At each neutral point, the resultant magnetic field is 0. Let us now study about making of magnets. Yes, this process of making of magnets is known as magnetization. The process by which a magnetic material, iron, nickel, cobalt, these are the magnetic materials, these attains magnetization temporarily or permanently is called magnetization. There are certain methods used for magnetization. These are magnetic induction method, single touch method, double touch method, electric method. The very first magnetic induction method. The phenomenon by which an ordinary piece of iron acquires magnetic properties temporarily for some period of time due to the presence of another magnet near it is called magnetic induction. In case of single touch method, we magnetize a magnetic material such as iron, nickel, cobalt by rubbing one single bar magnet against the magnetic material. Whereas in case of double touch method, we magnetize a magnetic material by rubbing two bar magnets against it. Electric method is a method to generate strong magnets. These strong magnets are nowadays made up of the magnetic material are made by electrical method. The magnetic effect of electric current was first discovered in 1820 by Danish physicist Hans Christian Ørsted. Ørsted discovered that a wire carrying electric current acts like a magnet. A magnet consisting of a coil of insulated wire wrapped around a soft iron core that is magnetized only when the current flows through it. This process of generating strong magnets by passing electric current is known as electric method. This method produces stronger magnets which are generally known as electromagnets. So let us come to the new topic, electromagnets. A type of magnet in which a magnetic field is produced through electric current is called electromagnet, and the branch of physics which deals with the magnetic effect of electric current is called electromagnetism. An electromagnet consists of a soft iron piece called the core on which an insulated copper wire is wound to carry current in the coil. When an electric current is passed through the coil of insulated wire, it behaves like a magnet, and certainly it becomes an electromagnet. But as soon as the current is stopped, the soft iron core loses its magnetism. So, an electromagnet is a temporary magnet which retains the property of magnetism only when the current is passed through it. But if the core is made up of soft iron, it can act as a permanent magnet. Now let us put some light on the types of electromagnet. There are two types of electromagnets: bar-shaped electromagnet and U-shaped electromagnet. You can see in the picture, the bar-shaped electromagnet is made when an insulated copper wire is wrapped around a bar-shaped soft iron core. Whereas the U-shaped electromagnet is made when an insulated copper wire is wrapped around a U-shaped soft iron core. In both the magnets, the two ends of the wire are connected to a battery through a switch. When the switch is turned on, an electric current passes through the wire and the whole arrangement behaves like a magnet. The end of the electromagnet where the current flows in a clockwise direction acts as south pole, while the other end where the current flows in the anti-clockwise direction acts as north pole. When the switch is turned off, the flow of current through the coil stops and the electromagnet loses its magnetism, or we can call it a temporary magnet. To make it a stronger permanent electromagnet, you need a soft iron core. Let us now study about the factors on which the strength of electromagnet depends. First of all, it depends on the amount of current flowing through the coil. As the amount of current flowing through the coil increases, the electromagnet becomes a stronger, and as the amount of current flowing through the coil decreases, the electromagnet becomes weaker. Thus, the strength of an electromagnet is directly proportional to the amount of electric current flowing through it. The second point, the number of turns per unit length of the coil. If the number of turns per unit length of the coil are less, a weak electromagnet is obtained. On increasing the number of turns of the coil, the strength of electromagnet can be increased. Thus, the strength of an electromagnet is directly proportional to the number of turns per unit length of the coil. Let us now study certain uses of electromagnets. An electromagnet does all the things that ordinary magnets can do, but you can switch off them or not. It is also used in electric bell. It is also used for sorting the scrap. It is used in speakers. It is used in switches. Now let us come to one of the applications of electromagnets, that is electric bell. The construction of electric bell has an electromagnet, a contact spring, a contact screw, armature, a hammer, a gong which is fitted to the flat wooden or plastic board. When we talk about the working, we need to see the diagram. In the diagram, you can see the terminals at the two parts of the battery. The negative part of the battery, we say the terminal T2. The positive part of battery, where there is a push button, we call it terminal T1. These two terminals of the bell are connected to the battery through a push button switch. When the switch is pressed, current flows from the battery to the electromagnet and then to the contact screw. From the contact screw, it finally flows to terminal T2 that lies on the negative side of the battery and again to the battery. Thus, the electric circuit is completed. As the current flows through the U-shaped electromagnet, it gets magnetized and attracts the armature made up of iron towards itself. As a result, the hammer attached to the armature hits the gong and the sound is produced. Due to the displacement of the armature from its original position, it loses contact with the contact screw. This breaks the circuit and the current stops flowing through the electromagnet. Thus, the electromagnet loses its magnetism. The spring pulls the armature back to its original position. This once again completes the circuit and the electric current starts flowing. The whole sequence of hammer hitting the gong is repeated as long as push button switch is kept pressed. This is a working, or we can call it application of electromagnet. Thank you for watching the video. I hope you like it.